My name is Christine Campbell, an instructor at the National Tool and Engineering Institute. Today, we will be demonstrating how to test short circuit current and open circuit voltage. Beside me is Leighton Hamilton, my demonstrator. By the end of this video, you should be able to identify required personal protective equipment when testing short circuit current and open circuit voltage. Select appropriate tools, equipment, and testing devices. Test open circuit voltage using a multimeter. Test short circuit current using a multimeter. Throughout this video, you will be exposed to these employability skills: compliance with relevant regulations, codes of practice, and OH&S requirements, adherence to organization policies, procedures, and instructions, safety consciousness for self and others, and finally, attention to details. These two tests are done on newly installed PV system to ensure that the panels are functioning at manufacturer's specification. For these tests, it is required that you have a PV module and a multimeter. We will also need overall and safety shoes. In using our multimeter, the dial must be on the correct scale, which is voltage we are checking. We must select DC voltage for our mode and also the range. The next thing to do is to insert our leads. Now our black lead always is placed where the COM is noted, which means the common. Our red lead will be placed in the other slot. We'll check the meter to ensure that the correct scale is selected, it is in the correct mode, and the correct range is selected. Once the meter is set, we can proceed in executing this test. The first thing we'll do, we have to ensure that our panel, we identify the leads. So we have a positive lead, the red strip indicating to us that it is positive, also the upward sprout and a plus sign is there to indicate to us that it is positive. Then the next lead will be our negative lead, which will receive the positive lead, and there's also a minus sign indicating the negative lead. We'll use our red lead to insert in the positive terminal of the panel, and our black lead in the negative terminal of the panel. And we are getting a reading of 38.92 volts. If this reading is not the same or a little less than the reading on the panel, the specification sheet, then it means that your panel is faulty. Now we'll be carrying out the short circuit current test. With this test, we'll be using also a multimeter. However, the scale has to be changed because we are now testing for current. Now, in selecting the range, it is important that we have an idea of the amount of current that we are measuring. The scale that we will be using based on our range on our meter is 60 amp. We'll be setting our mode to DC because it is DC current. We can now go ahead and connect our leads, observing the same polarity. So the reading should be similar to that of the specification sheet, which the manufacturer said should be 8.72 amperes, which would have proven to us that the panel is working. Let's review. In order to carry out both tests, we must ensure that our multimeter is set on the correct scale, range, and mode. Likewise, our leads are placed in the correct ports. It is important to check your reading against the specification sheet to ensure that your panel is functioning to manufactured specification. Thanks for watching this video on performing a short circuit current test and open circuit voltage test on photovoltaic array. You should have learned the correct way to identify required personal protective equipment when testing short circuit current and open circuit voltage. Select appropriate tools, equipment, and testing devices. Test open circuit voltage using a multimeter, and finally, test short circuit current using a multimeter.